Welcome to Devices 2. This is Professor Lake, and this is Lab 3, the monostable 555 timer. Today we're going to cover in this video the first part, which is the Astable 555 timer. First thing we're going to look at is down here at this chart, where it tells you to do your F calculation and your D calculation for these three different sets of resistors. Resistor A, which is up here, and resistor B, which is here. You can find the formulas for that on slide 29, where we find the frequency formula here and the duty cycle formula here. Now the 555 timer is called that because it has three 5K ohm resistors built into the chip. And so it would be a 555 timer. So next, after we've done these calculations, we're going to build this circuit, which I've already done on multisim. When you're looking at the 555 timer, there's a dot here. This dot is what will tell you what the first leg is. So here's the first leg. Now the legs numbers go around the chip. So this would be 1, 2, 3, 4, 5, 6, 7, and 8. So with the circuit built and our resistors A being a 10K ohm resistor and our resistor B being a 100K ohm resistor, we're going to start up the simulation and look at our oscope. So to get a good look at it, we're going to pause and bring it back. This is really big, so we're going to increase the scale for our timing. So to do our formula, we need to first find out our frequency. Okay, so, sorry, not for our formula, but for our measurement. We need to look at our frequency. To determine the frequency, we have to count the time of one full wave. So, looks like for this full wave, remember that we have it set for 500 microseconds per division. So that's from here to here is 500 microseconds. So, each little tick will be 100 microseconds. So all we have to do is count the ticks between this and this. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and a half. So punching it into your calculators, we're going to punch in 1,450 microseconds, so it's going to be shift micro, and then we're going to do the reciprocal to find our frequency. That gets our frequency at about 689 hertz. So that's how we find the frequency. To determine the D measurement, we have to figure out what percentage of this wave is up. That will give us our duty cycle. So we can use these measurement tools as well. So this is telling us that the total time for the wave is 1.467 milliseconds. For our duty cycle, the part of the time that is up, it's 769 milliseconds. So that's half. That's a 50% duty cycle. Now we're going to go through and do it with the other two sets of resistors. So we're going to change resistor A to 100 kiloohms. Got to turn off the simulation. And set resistor B to 10 k ohm. Fire this up. See what our oscope is showing us. Alright, so to find our frequency measurement, this time we're going to use these flags here. So from where it goes up through its full wave to where it goes up again, we have 834 microseconds. So we punch that into our calculators. Do the reciprocal to find your frequency, which I found at 1.12 kilohertz. Now to find your duty cycle, we're going to take our up portion, which is at 765.353 microseconds, and we're going to divide that by the total wave, which is 834.097 microseconds. And it gives us a duty cycle of almost 92%. And let's do the last set of resistors, where they're both 10 k ohm resistors. Start the simulation. Take a look at our oscope. And see what we got here. Okay, I'm going to make this a little bit wider. Once again, use our flags. get our times. And this is telling us that the time for one full wave to pass a point is 208.983 microseconds. So we punch that in our calculator. And we hit the reciprocal to find our frequency, which I found at 4.78 kilohertz. Now to find our duty cycle measurement, remember we want to take our uptime, which is 139.322 microseconds, and divide it by our total wave time, which is 208.983 microseconds. That gives us a duty cycle of 67%. So that concludes our Astable 555 timer video.